Chapter 4 is all about sampling and experimentation in statistics. We're starting with sampling methods and bias. Why do we need to take samples, you guys? Yes, Danny?
So we don't have to do the whole population.
Yeah, absolutely. So here's the deal. Suppose we want to find out what % of young drivers in the U.S. text while driving. None of you do that, right? Ideally, we would like to ask all of them their opinion and have the best data possible. But is that realistic, you guys? No. Instead, we're going to take a sample. Instead, we're going to take a sample that will be chosen to represent the entire population of young drivers. Just so you are clear, the entire group of individuals that we want information about is called the population. The entire group of individuals that we want the information about is the population, okay? But since it doesn't make sense to talk to everyone in the population, because that's time-consuming and unrealistic, we're going to take a sample. Now, a sample is a part of the population, and this is very important, that we actually examine. So we get their actual data. Those are the people that are in the sample, okay? A sample is part of the population that we actually examine in order to gather information. Sampling, this is just the definition of sampling. It involves studying a part in order to gain information about the whole. That's the sampling. We're studying a part of the data in order to get information about the whole. Sampling. All right. A census. What is a census, you guys?
It's like a count of the people.
Who do I talk to whenever I take a census?
Government.
Everyone.
There we go. A census collects data from every individual in the entire population. A census collects data from every single individual. Can you take a census? Sure. Is it time-consuming? Yes, especially for really big populations. For example, the United States of America. They take a census. How often do they take it?
Every 10 years.
10 years. Why do you think they space it out every 10 years? It takes 5 years just to get all the stinking data. They literally will send you stuff in the mail, call your work, call your home. They'll come to your house and knock on the door and say, you haven't turned in your census data. I need to get it from you. They literally will hunt you down to try to get your data from them.
Okay, if we haven't handed in the census data, but they know that we haven't done that, so that means they know that we're there.
Exactly.
That's silly.
I know.
The IRS,
Isn't that weird?
Like, they know exactly how much you got to pay. Just make it
I know, right?
Right.
Another definition, a sampling frame. A sampling frame is the list of individuals from the sample, from which the sample will be drawn. It is a list of individuals from which a sample will be drawn. That word should say which, not with. From which a sample will be drawn, not with. I'm so sorry about that typo.
I messed up the entire
A sampling frame is a list of the individuals from which the sample will be drawn. So, if I'm taking a sample in McKinney-Boyd High School, what's the sampling frame?
however many people here.
It's a list of all of the people at McKinney-Boyd High School, okay? And then I take a sample, I select people, and I talk to them, and they become my sample once I get their information, okay? If I wanted to take a census at McKinney-Boyd High School, who would I talk to?
Everyone.
Every single student at McKinney-Boyd High School. Got it?
Yes.
Cool. All right, perfect. Moving on. The design of a sample. The design, that's supposed to be a word you write in. The design of a sample refers to the method. The design is the method used to choose your sample. There's tons of different ways to choose your samples, you guys. Actually, specifically, there's 5.
Only 5?
Actually, there's 6.
What's the sixth way?
It's not on here. We'll talk about it later. So there's 6 that we're going to talk about this year. These are the 5 most common ways. So we've got voluntary response, convenient, simple random sample, stratified, and cluster. Have any of you heard of any of those before?
Maybe.
Yeah.
Which one?
Cluster.
You've heard of cluster? What is cluster sampling?
It's random.
Random groups, okay, possibly.
Like
No,
within the
you
population.
choose like a group of them.
In the sampling frame, so in the list of everybody, you choose like a group of them. Okay, possibly, yes, good. All right, so these are the ones we're going to talk about, okay? We're going to talk in detail about these 5, and then like I said, there is a 6th one. We'll talk about that probably tomorrow. All right, so why are we doing this, you guys? Why are we talking about sampling? It's so that we can make an inference about the population. What does the word inference mean?
Conclusion.
It means to conclude or to infer something, to make a conclusion about something. So, one survey. If I take a survey at McKinney Boyd High School about, I don't know, what's a hot topic around here? Cafeteria food. I take a survey about the cafeteria food, and I randomly sample a bunch of 100 kids out of McKinney Boyd High School. And I do that on a Monday. And then I do another random sample on Wednesday of 100 kids. Will the results be exactly the same both days?
Probably not.
No. But if I did a pretty good sample method, then I should have similar results, okay? If I did a good sample method. So, yes, there's going to be some variance from sample to sample, but they should be pretty close to what the population thinks. So, due to the laws of probability, we can estimate a margin of error, which we'll talk about that like a long time from now. But usually our sample is going to be pretty close to the population if it's a good sample method, okay? Let's see. Larger random samples give more accurate results than smaller samples. Why? Why is that?
Because the more people is the closer to the.
Yeah, the closer I get to getting a census, the more I've got the representation of the entire population. So, like, if I only take a sample of 10 people, what if I just, like, randomly have selected, by random chance, like, 10 people who don't eat in the cafeteria? Well, then, I mean, that could happen. Then their opinion of the cafeteria food is not going to really matter because they don't even eat there. So... But if I take a sample of 100, the chances of me getting 100 people that don't eat in the cafeteria are a little slimmer, okay? But again, I do remind you guys, it is almost impossible to take a census every time, okay? Remind me again, what's a census? Everybody in the population gets selected. Okay, so here's a picture of what we're doing, okay? This circle here represents the population. From the population, we are going to take a sample, all right? So we're going to select subjects from population, and this is my sample now. Now look, where did my sample come from, you guys?
The population.
It came from the population, right? So like here's the sample within the population here. But I select those people. Those people, this sample right there, hopefully, okay? Hopefully, these represent the population well. Meaning I didn't get all upperclassmen in the population of McKinney Boyd High School. I didn't get all freshmen in the population of McKinney Boyd High School. Hopefully I got a little bit of everybody in that sample. Hopefully. That's the point. Hopefully I did a good method. Then what do I do with that data? I infer the truth about the population. I infer the truth about the population. Because again, I don't have time to talk to 2,615 children about their thoughts about the cafeteria food. So I'm going to get a good representative sample, hopefully, from the population. And then I'm going to say, you know what? I think this looks enough like the population that I can say now what McKinney-Boyd High School as a whole thinks. And that is honestly how most of our data gets to us, right? When we have data about the heights of people, do you think that we have measured the heights of all people?
No.
No. We have taken a random sample of people and we say that that's the heights of all people. Okay? Do you guys have any questions about how this works?
No.
Perfect. Then let's talk about how to do some samples.
Yeah.
Oh, actually, we're going to do one thing first. Sorry. Here's an example. This might be what something would look like on a free response question.
All right, let's run.
The McKinney-Boyd High School newspaper plans to survey local businesses about the importance of students as customers. From an alphabetical list of all 857 local businesses, the newspaper staff chooses 150 businesses at random. Of these, 73 return the questionnaire mailed by the staff. Identify the population and the sample. Discuss it with your group. You have 30 seconds. Ready, go.
Population is the sample is the 73. Yes, because the people who actually did it. It's the people who actually did it. It's your sample. Your sample is the actually examined.
Okay, so the population is 857, so the sample, I guess the sample is 73.
No, the population is 173.
No. It's like there's a sample.
5 seconds.
There's a sample after the sample. Because like those are the people they're actually going to be able to talk to. They just sent that out to 150. But like only 150, only 73 of them.
All right, ladies and gentlemen, please tell me who is the population?
857.
857 local businesses. That is the population that we are trying to infer data about. We're trying to infer data about what local businesses think. So there's the 857 local businesses. And now, what's the sample?
It's 73. It's not 150 because like some of them didn't even respond. So like they don't count.
No, facts. It really do be 73.
Like they wouldn't count because they didn't answer.
Sample. What is the definition of a sample?
The people who actually.
It is the people that we actually analyze the data of. So I sent the data, or I sent the survey to 150 people. Some of them didn't respond, and so I don't have data to analyze on those people. So my sample is just the 73. Number one missed question on the free response of this test?
Really?
Something like that.
Yeah.
Yeah, we ain't gonna miss that.
We ain't gonna miss that. Not this year.
I'm the
We're
smartest-
smarter than that.
I'm the smartest class we ever had.
All right, you guys, let's talk about how to sample badly before we talk about how to do it right. So the first thing is taking a convenience sample. By the way, in case you guys haven't noticed, I don't necessarily spell every word 100% correctly. So if you guys ever see me spell something wrong, feel free to let me know.
Pretty sure that's correct.
I mean,
I've been to many 7-Eleven.
well, no, I for sure have spelled convenience wrong today, but no one tells me. But I just want you guys to know it doesn't hurt my feelings if you're like, hey, that's wrong. Okay.
This type of sampling.
I might change it, I might
Hold
not.
on. Miss Lakey, can I put in my bet right now?
What?
That's gonna say bias.
Oh, let's see. Convenience sampling chooses the individual's easiest to reach.
Either that or like.
This type of sampling produces unrepresentative.
Don't talk to me.
Unrepresentative. Is it an A?
It isn't that.
Unrepresentative, like
I
that?
remember that because like representation.
Okay, there you go. Unrepresentative data. What does that mean, unrepresentative
It
data?
doesn't represent the population.
It doesn't represent the population, but why? If it's convenient, seems good.
Because it's not proportionate.
Yeah, I'm not really getting the people who represent the whole population. I'm just getting people that's easy for the interviewer to get to. Here's an example. Oh, hey, this might be something like you would see on a free response.
Really?
Suppose we want to survey McKinney Boyd High School students and find out how long they spent doing their homework last week. So for convenience, Miss Lakey stands right outside her door and asks the first 30 students she sees. Now, this is a convenient sample. It's convenient for me to take the survey. Convenient sample is always convenient for the interviewer. Okay? What's wrong with this? Why is this a problem?
You're in a math hall.
I'm in a math hallway. What if students who don't take a math class this year because they already got all their credits and they're like down there in fine arts or some other fun class that doesn't have homework, right? So like probably not a good representation. What else might be a problem?
You're going to see a lot more than 30 students for a day.
Said, oh yeah, so I'm just seeing like the same 30 students that are in like maybe I did this first period, which is my academic stats class, and so I'm just asking them. So like I'm not asking AP students at that point, so I might not be getting AP kids.
Don't want to like a diverse.
Well, yeah, I need to get a diverse representative sample of McKinney Boyd High School students, not just Miss Lakey's first period's regular stats class. Okay, so like that might be a problem. What else could be a problem?
They could lie.
Somebody at the door.
They might lie. Are you here to lie?
No, I'm not. Could I take the
We could have liars. We could have the what? Who walks down this hallway on the upstairs L hall? Upperclassmen usually, unless they're like a freshman in Algebra 2. Otherwise, it's mostly upperclassmen. So, the problem here is that it is not a good representation of the population. By the way, you guys, that is always going to be the problem with a convenience sample. It's not a good representation of the population. I'm just doing what's convenient and fast for me, not necessarily what's a good representation of the population. Have any of you guys ever come across those people at the mall that are taking surveys?
Yeah.
Why is that bad data?
They're annoying.
Cause it's like, bro. Go
Other than them being annoying, let's say that they're asking questions about, unemployment. Who's at the mall?
unemployed, like, come on now.
Probably people who have a job and have money to spend.
Like, they gotta
Right?
like the school.
Just saying. Teenagers who are bored.
If you want to
Could be
talk
that
about
too.
unemployment, like
don't want to be answering the surveys.
The people at the mall are good.
Right? Or they're like, don't talk to me. Yeah.
Like, Aaron, you go to the mall.
We'll talk about what that's called later. All right, here's another, here's the problem. This produces bias. This produces bias. The design of a statistical study shows bias if it consistently under or overestimates the value that you want to know. So guys, if I take a random sample of McKinney Boyd High School students and I randomly get a sample of all upperclassmen who take AP classes, that's just kind of crazy. Like, it randomly happened that way. But if I do it again, I should get a better representation. And if I do it again, I should get another better representation. Okay? And so as I'm taking this sample over and over, now wait, if I take a sample and I get all upperclassmen who are in AP classes, and then I take a sample again and I get all upperclassmen who are in AP classes, and I do it again and I get all AP classes, like what? Now what?
Go buy a lottery ticket.
I need to look at my sample method because something about what I'm doing is causing a problem. Okay? So, bias is the result of a bad study design. Bias is a result of a bad study design that will consistently miss the truth about the population in the same way. Okay? The design is biased if it systematically favors a certain outcome. I go to the donut store and take a survey about health food. Am I going to get a biased answer? Every time. Every time. Okay? All right, guys, another type of sampling that shows bias is voluntary response. This type of sampling is when people choose themselves to respond to a general invitation. Now, here's an important part of it. The invitation to take part in the survey is available to everyone.
How do you?
So here's an example. I want to take a survey at McKinney Boyd High School about cafeteria food. I put a survey in your Canvas homepage. Everybody has access to it. It says, survey about cafeteria food. Who's going to click on the survey?
People who want to talk about people who don't like.
Maybe no one. People who don't like the food and they want to give their opinion about it.
How do you know?
Because they are.
What do you mean?
Like, how do you?
Let's be real.
How do I know who's going to click on it?
How do you okay? So you have 50 students who click on the thing who all don't like cafeteria food, and that's why they click on it, and it all comes back as they all like cafeteria food. Versus like just a diverse range of people who all click they don't like cafeteria food.
So think about any kind of a voluntary survey. So have you guys ever been to Whataburger? Did you know that on the bottom of a Whataburger receipt there's a link that you can take a survey?
I did.
And how many of you have ever actually taken the survey?
Absolutely not.
Why not? That's a voluntary response. Everybody gets the survey link on their receipt, but why don't you guys take the survey?
Because I don't have anything to say.
You have nothing really to say. Now let me say this. What if you go to Whataburger and you find hair in your food? Are you gonna let someone know?
Yeah.
You gonna probably fill out that survey now that you know it's there. Okay?
That's all I'm saying.
So, voluntary
Oh,
response.
they're bad, so we don't like voluntary.
Oh, by the way, here's my favorite voluntary response. In our country, our democratic voting system is a voluntary response. As long as you're registered to vote, you can go vote. But who goes and votes?
People who are upset.
People who are passionate or unhappy about the way things are going, and that's why you have non-voter bias, and that's why we have issues. I'll stop there. All right, so look at this question. Former CNN commentator Lou Dobbs doesn't like illegal immigration. One of his shows was largely devoted to attacking a proposal to offer driver's licenses to illegal immigrants.
Bro, what?
During the show, Mr. Dobbs invited his viewers to go to www.loudobbs.com and vote on this question. Would you be more or less likely to vote for a presidential candidate who supports giving driver's licenses to illegal aliens? Here's the results. 97% of the 7,350 people who voted by the end of the show said that they would be less likely to vote for that presidential candidate. What type of survey did Mr. Dobbs use in his poll?
Wait, what's the
Use a
question?
voluntary.
It was voluntary.
This is voluntary response.
And it's to a very biased crowd.
Common sense.
This is voluntary response. Okay, everybody that was watching his show could have gone to the website, so everybody could have seen or taken the survey, but this is voluntary response. Who do you guys think actually took the time to get on their internet and go to the survey and take it?
His followers.
People who are like,
People are like, don't you dare give those people those driver's licenses, right? All right, now,
that's who they are.
what is the problem with this whole survey?
It's voluntary.
And so the people who
So the people watching him are gonna say they don't like
The
it.
guy doesn't like illegal immigrants anyway. And so people who are watching his show, the population, right? The people who had access to this survey, they probably already agree with him. Otherwise, would they be watching?
No.
Probably not. And so chances are we're getting a very biased answer. Now, here's the hardest part, you guys. What direction is the bias in? Is the 97% an overestimation of the true population's opinion, or is it an underestimation of the true population's opinion?
Overestimate.
Very good. 97% is likely an overestimation of the true value. Again, we've got people who already support him, who are like-minded with what he believes, and he puts out a voluntary response poll where passionate people are going to be the ones that go seek out the survey.
Somebody who has worked construction, like illegal immigrants.
All right, let's talk about something even more controversial.
I'm not ready.
Orange juice. A farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy oranges. Identify the sampling method used.
It's convenient sampling.
How is this convenient sampling?
The tops, they're easy to see.
Dude, the inspector's like lazy. He's like, crate, good, great, buy. Crate, bad, great, buy. This is convenience sample. Again, I want to point out it's convenient for the interviewer or the surveyor. So it's the company inspector that this is convenient for. Now, guys, what do you think the farmer's going to do once he realizes that the inspector's just looking at the top of the crates?
You get angry.
He's going to put the good ones on the top. Have you guys ever seen an orange that has gone bad?
Yeah, it's grody.
It's like green and fuzzy and really smushy. It's nasty, okay? So, farmer might throw some of those down in the bottom or in the middle of the crate or something, right, to kind of fill the crate up. And now this guy's going to buy this crate, and I mean, it just is what it is, right? What are we doing back there? Are we looking up oranges and crates? Uh-huh. All right. Now, what direction is this bias in? Do you guys think that this sample is going to overestimate the quality of the oranges or underestimate the quality of the oranges?
Because he's gonna start putting.
How many are it's not the actual quality.
Nah, but like that means that they're gonna overestimate how good they are. Because they're not.
So think about the whole situation. Farmer figures out guy's only going to look at the top 10. He was going to probably put the best 10 on the top. This is an overestimation of the quality of the oranges.
Everybody got to get it. This farmer trying to scam the good people of America.
Farmer's just trying to get paid, man.
It's actually so real.
Now, whose fault is this?
That's the,
This is the inspector's fault. Farmer just got smart. I'm just
It
saying.
depends on your moral value.
I mean, yeah, sure. All right, cool. What questions do you guys have about convenient sample or voluntary response? Both of those are not necessarily the best, okay? Both of those are not necessarily the best. Now, can we do it? Obviously, we stake our claim on who's going to be the president of the United States on a voluntary response poll.
yeah, but it goes.
Yeah, the Electoral College and all that, blah, blah, blah. All right, cool.
Because everything's.
So how do we sample well? If that's how we do it poorly, how do we do it well?
Not good natured.
In a convenience and voluntary in a convenience and a voluntary response sampling, both suffer from bias due to personal choice. The best way to avoid this problem is to let chance choose the sample. That's the idea of random sampling.
Is that really the best way to go about this?
Yep. Well, sort of.
It seems like
Now, this involves a chance process to determine who's going to be included in the sample. The easiest way, you guys, to get a random sample of N people, what does N stand for? Do y'all know?
The amount.
N is your sample size. Little n is sample size. The easiest way to choose a random sample of n size is to write their names on identical slips of paper, put the slips in a hat,
Drop from the hay.
a container, basically, mix well, and pull out slips one at a time until you have n number, whatever sample size you want. This results in a simple random sample, also known very commonly as an SRS for
Oh,
short.
okay.
Now, this is called the hat method. Literally, it's called the hat method in the real life statistical community. Okay? Why is this called a hat method?
Did you draw it down?
You think about putting like names in a hat and drawing them out, right? Does it have to be a hat, you guys?
Yeah.
No, it can be a container, a box of whatever.
If you
But
draw
here's
it
the
down,
thing.
you draw for it.
When you are explaining the hat method, you have to include the mix well. Mix well is part of the process of the hat method. Why is that? Why do I have to say that you're going to mix well?
That way you don't like put them. You don't put them in like certain. It's like cards.
Think about it, you guys. If I printed out a list of McKinney Boyd High School students, 2,615 of you, and I put them in, I'm cutting the paper and putting it in, cutting the paper, putting it, like cutting all the names apart. I'm going to have A's at the bottom, then B's, C's, D's, E's, F's, G's, blah, 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 all the way up to Z's. So then I don't do anything, and I just reach in and start picking. Who's getting picked?
All the people at the
People at the end of the
Z's.
alphabet.
Miss Lakey,
So, mixing well is a part of it, yes.
what's the judge on mixing well?
Oh yeah, who decides when it's a mixed
What's
well?
mixing well?
All you have to do is just say mix well. So, like, you just shake it. Yay.
No, yeah, but like.
I mean, as long as you say mix well, you've covered your bases.
Turning up or go to.
Now, wait a second, you guys. An SRS, this is the actual definition of a simple random sample. An SRS of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. So, McKinney Boyd High School's population, 2,615. I want to select 100 students. Every grouping of 100 students has to have an equal chance to be selected. How many groupings of 100 students are there? A whole freaking lot, okay? Yes, there's a mathematical formula to figure that out, but it doesn't matter. There's a lot of different options of 100 students out of 2,615. But every single one has an equal chance of being selected. That's the definition of an SRS, okay? Here's the problem with the hat method, you guys. The hat method doesn't work very well if the population is too large. Why is that?
It's too many.
It won't fit in that.
I know they have 10-gallon cowboy hats, but come on, right? It's too big for a hat. So we can use a random number generator in order to choose our sample. Or we can use a table. So here it is. Selecting an SRS using a random number generator. There's two things you can do. You can use your calculator. Did you guys know your calculator has a random number generator on it?
Yeah.
Sure does, right underneath math and probability. Don't do it now, but it's there. We will do it at some point. So, here's the kicker though, you guys. You have to label the people in the population. You have to label each person in the population from 1 to capital N. Any guesses what capital N is?
All the pop, the way no, the
That is the number in the population. Now, technology is one way to do it, or table D. Do me a favor, guys. Look at the back of your notes.
back of
The back side of your notes.
going.
That is table D.
Oh my goodness.
This is the table of random digits. This is only used in a statistics class. This is not used in real life statistics. The only reason that we would not use a random number generator in statistics in class is because if we allowed you guys to use a random number generator, you can all randomly get different answers to the test. And I could never grade it.
But that's not really.
This is a way that we can randomly select and all get the same random answers.
That is.
This is table D. Notice that on the far left, that's not table D. This is table D. Notice that on the far left, it has line numbers starting at 101 and going to 150. Okay? Basically, that's how you know what line to go use. I'll say, use line 107, and you'll use that line. We will start tomorrow with me showing you how to use this.